Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. Today, as I mentioned earlier, I want to go over power series. We talked a little bit about power series last time. Today, we are going to check whether or where the power series converge, and that would be our job. So when I say power series, I have an infinite sum going from 0 to infinity of some function of x. So let's say x minus a to some n power, right? N or 2n or whatever. And it may be multiplied also by some other number here, like 4 to the n over n factorial. There are a bunch of n's all over the place. And we want to see if this power series, or where does this power series converge? Why did I say where, not if? Because any one of these power series will definitely converge when x equals a, right? Because you will get 0. Uh, a word of caution. I may hear some of you say, but the first term would be 0 to the 0, which is undefined. No, for the sake of this course and to simplify things, we assume that, we don't have the first term. It's like not 0 over 0. It's just 0 to the first power or something. So just here, we are going to assume that 0 to the 0 is 1. It's not, by the way, in real life, it's not 0 to the raised to the power of 0. But in order to be able to write it succinctly, and without loss of generalization, we are going to say that don't worry about this thing. This is like a minor thing, and it's not really 0 to the power of 0. Maybe you'll see it later when we work. But we know for sure that x equals a will converge, right? When x equals a, it converges. So that's why we call that the center of convergence. And this is the easiest thing anybody can find. But just if x by itself, then the center of convergence is 0. If it's anything else, you just subtract that number. Center of convergence is a. X equals a. But does it only converge at a, or are there other values where it converges to a? Well, if we have, or whether we do or we don't, but if we have some values between which this series is converging, then we can define the radius of convergence. Notice that the point A would always be the middle of the two ends of the convergence interval, if it exists, right? It's like you draw a circle. That's why we call it radius of convergence. And we are going to call that R. We'll see how we find R. So the interval of convergence will simply be A minus R to A plus R. But now we can either have one side a parentheses and the other a bracket, or one side or both parentheses or both brackets. Meaning, if I reach that stage, I have to check, what if x equals a minus r? Will it converge or diverge? What if x equals a plus r? Will it diverge or converge? So this will be the topic of next session. Today, I'm going to look at specific cases, okay? The radius of convergence. If the radius of convergence is 0, it means this thing will converge only when x equals a. Oh. And if the radius of convergence is infinite, then it doesn't matter. It converges no matter what the value of x is. But if it's somewhere in the middle, so the radius here is greater than 0, less than infinity, I will have to check at these two extremes, two values, the lower limit and the upper limit, does it converge or diverge? Okay. So we are going to discuss that next time. We are going to look at these two cases today because they are easy. This is not hard, but it needs more work. Today, we are going to do that because, I don't want it to be a very long uh, session. And notice here we have to take some cases where the left-hand side is in and the right is out, or both are in or both are out. So we can have like maybe 3 examples to cover all these bases. Okay, so we'll see today how we are going to check. 2 things to keep in mind. The first one is that we will always use the limit comparison test for this type of series. I didn't go over the different tests of convergence of series because I wasn't just, doing a whole course. I'm just selecting topics where I think we need to elaborate on. But if you want, we can do one on different tests of comparison. So the limit comparison test is basically you take the limit as n approaches infinity of the next term in the series over the current term of the series and see if the absolute value is less than 1, it will converge. If it's 1 or more or -1 or less, it will diverge. Okay, it's as simple as that. The second thing you have to be careful of, one series that we may encounter a lot, it's called the harmonic series. And the harmonic series is this series, summation n going from 0 to infinity of some kind of any number here, let's call it b, over n. And this one diverges. Even though some people think, why would 1 plus a half plus a third, since these numbers will get smaller and smaller and eventually go to 0, why does it diverge? Well, that's not the topic of today, but you can prove that using the other tests that you learn about. But why I'm saying that? Because sometimes when you substitute here to find these 2 points, you end up with a harmonic series. You don't need to prove when you reach that point. You don't need to prove that it diverges. You can take it as a common knowledge. Okay? Or the alternate, meaning it goes positive. The first term is positive, the second is negative, the third is positive. Harmonic series is the summation of n going from 0 to infinity of some number b multiplied by -1 to the n over n, and this one converges. Again, you don't need to prove it. It's just that. Okay, so keep these 2 remarks in mind because we will be using them a lot. Let's take a couple of examples. One where, for example, we get a radius of infinity, and one we get the radius of 0. Okay, and then if it's somewhere else, something else, we are going to discuss that next time. So suppose here I want to check this series, n goes from 0 to infinity of 2n factorial. It's not 2 times n factorial, no, 2n, but all of it factorial times x to the n, or maybe you can also make it 2n over n factorial. Where does it converge? Okay. So as we said, we are going to use the limit comparison test, which says take the limit as n approaches infinity of the absolute value, because I want the absolute value to be less than 1, okay? Not less than or equal. If it equals 1, you will go to infinity. As I said, if you keep adding 1, 1, 1 infinite times, you go to infinity. So I will divide the n plus first term over the nth term. N plus first, meaning every n will be changed into n plus 1. Notice n here is multiplied by 2. So we can write it like 2 times n plus 1 factorial x to the 2n plus 1 over n plus 1 factorial, and then I divide by that. So this goes into the denominator as 2n factorial x to the 2n, and this one goes up as n factorial. Okay, I'm going to take it step by step. Then I would say this is the limit as n approaches infinity of the absolute value of, here I have 2n plus 2, right? So it's 2n plus 2 factorial times x to the 2n plus 2 n factorial over. And then just to save time, well, we can write this as n plus 1 times n factorial. This is 2n factorial, and this is x to the 2n. Limit as n approaches infinity of. Here, I can simplify x to the 2n, and this would be x squared, right? Because I subtracted 2n. Here I have n factorial and n factorial. So now what remains to be done is to rewrite this as 2n plus 2 times 2n plus 1 times 2n factorial x squared over n plus 1 2n factorial, and these two would cancel. So now I need to take the limit of that. Notice that the numerator, the n power is 2, right? If you expand that, you will get 4n squared plus 6n plus 2 divided by n plus 1. So as you learned, when you take the limit as n approaches infinity, if the numerator has a higher degree, that whole thing goes to infinity, right? So, and otherwise, you can divide top and bottom by n squared, all the terms by n squared. So if you divide n plus 1 by n squared, that goes to 0 because, and the numerator, you get 4. So basically, or I'm sorry, if you divide by n, so this would go to 1, and this would go to 4n, and 4n as n approaches infinity will be infinity. So this limit is infinite. So no matter how big or small x is, eventually this limit will go to infinity, meaning I cannot have any, x has to be 0 here. The center of convergence is 0, right? If x is 0.1 or negative 0.01, this whole thing will go to infinity. Why? Because the numerator has n squared and the numerator has n. So as n goes to infinity, the whole thing goes to infinity. Meaning my radius of convergence is 0. There is nothing other than x. And the interval of convergence is simply the number 0. And that's how simple it is. If this thing equals infinity, meaning you cannot make it less than 1, no matter what, right? It doesn't depend on x. It depends on the power of n here. So that's basically the first example. Maybe we get another piece of paper and we take another example here. Let's say example 2. Summation n going from 0 to infinity of 3 to the n times maybe x, whatever, plus or minus 5 to the n over n to the n. And we want to check that. Again, the limit comparison test says take the limit as n approaches infinity of the absolute value of the next term, which is 3 to the n plus 1. Notice here I didn't have a problem. There is no something multiplied by n, so I don't need to expand anything, times x minus 5 to the n plus 1. Notice that this is, okay, I'm not going to elaborate on that, over n plus 1 raised to the power of n plus 1. So that's the n plus first term. I'm going to divide that by what I have here, 3 to the n, x minus 5 to the n to the n. And I want this to be less than 1. Okay, so that becomes the limit as n approaches infinity of the absolute value. This over that is 3. Notice the number is irrelevant here. It's relevant later, of course, but here it doesn't have n. That's what I meant. And this over that is just x minus 5. So I simplified this with that. I simplified this with that. And now I have n to the n over n plus 1. Excuse me. N plus 1 to the n plus 1. Do you see that that will go to 0? If you don't, what can we do? How do you find this limit? Think about it and see what will happen. First of all, let's say the center here, center of convergence, is 5, meaning x equals 5 will definitely work. But what happens here when n goes to infinity? Meaning, if I divide top and bottom by n to the n, the numerator would be 1, and the denominator is what? You can write this as n plus 1 to the n times n plus 1, right? Divided by n to the n. The limit of this is 1, so these would cancel, and you end up with an n in the denominator, meaning as n approaches infinity, this whole thing is 0. So that equals 0. It means no matter what you use for x, a very large number, a very small number, it will always be less than 1. Hence, the radius is infinite. And my interval would be negative infinity to positive infinity. And I'm done. And we saw that these two cases are the extreme cases where the radius is a point. So you get only the center becomes the interval of convergence. It's 1 point. Or the other extreme is that you get the limit equals 0. The next term over this term is smaller. The limit goes to 0 as we go to infinity, so that series will converge no matter what. And notice we are taking the absolute value. So whether x increases very much or decreases very much, you will always get the limit less than 1. I hope this was easy. I mean, if you have any questions, please let me know by dropping me a note in the comment sections and section, I mean, and I will come back or get back to you as soon as I can. Otherwise, I hope to see you next time, which will be more interesting than today, because today were really two extreme cases. Next time, we are going to see how do we find the interval and how do we check the limits of that interval, whether my series converges or diverges at these 2 points. Thanks and have a great time.